Yes, students. Today we are discussing a second bit of paper 1 unit 2, that's a covalent bonding or directional bonding. You have already studied in the last year the Lewis concept for acid and base. Preferably we have discussed a species or compound which possesses lone pair. It is called as Lewis base, and other a compound which accepts that lone pair is called as Lewis acid. But in particular, a number of bonds, how many are there, accordingly geometry, likewise the explanation was there by the Lewis concept. Acid base concept is there. By the way, Pauli theory, which is forwarded or put forwarded after the Lewis theory. So those theories were there by which we could able to understand geometry of the molecule. Then you have studied V.S.C theory. Will you explain what is the long form of that V.S.C theory? You have to unmute and talk. What is meant by V.S.C? Last year it was there in your syllabus. Only I am expecting the long form of V.S.C, and in 11th and 12th standard also you have studied it. Yes, valence
shell electron pair.
Help me.
Valence shell electron.
Right, Saurabh. Prathamesh also has given the right answer. Valence shell electron pair repulsion theory, depending upon the number of bond pairs and the lone pairs, we are deciding the geometry and the number of lone pairs, their position. With the help of that particular explanation about the geometry we could provide, that was the legacy of the V.S.C theory. But still, we are not happy with the performance of the V.S.C theory. V.S.C theory could not explain the bonding. V.S.C theory could not explain the energetics of the molecule during the formation of the bond. V.S.C theory could not explain the paramagnetism or diamagnetism, means magnetic properties, colors. Many problems are there in the V.S.C theory, and in order to avoid those problems, we are studying now a new theory called as valence bond theory. You might be knowing that valence electrons are there and if one pair electrons are there, then the pairing of the electron will occur and the bond can form. Yes, absolutely that. But a mathematical explanation or the quantum chemistry based explanation is involved there in the valence bond theory. Means Heisenberg uncertainty principle, or after de Broglie equation, whatever the modern quantum approach is there, no, that we have to discuss. Means what that modern quantum approach considers? Modern quantum approach considers electron as a wave. Till now we were considering electron as a particle, so one cloud will be there. Cloud in a sense, what, one orbital and other orbital. Actually that orbital means a cloud of electron. It is because of Heisenberg uncertainty principle or Heisenberg uncertainty principle, you can say. A cloud of electron and other cloud of electron, they will overlap and the common region will be there. So that overlapping can also be mathematically described. And if we solve those mathematical expressions, means Schrodinger equation, then we can get the value for the energy. We can get the value for internuclear distances. That's the importance of the quantum approach to the formation of the molecule. And valence bond theory first time attempted to solve that quantum approach, attempted to describe that quantum approach. Before that, let us see what are the basic postulates of valence bond theory. The first postulate, covalent bond is formed when two valence orbitals which are half filled means there will be the one electron in each orbital belonging to different atoms, means orbital of one atom, maybe hydrogen, other atom, maybe hydrogen or chlorine or any other. But two atoms should be different, maybe of the same element or not, that's a different aspect, but orbitals should be of different atoms. They will overlap with each other. What is the result of that? Covalent bond. So what is the basic postulate of the valence bond theory? Valence bond theory considers two different orbitals and overlapping between those two different orbitals, that's resulting the covalent bonding. Then we have to think about the electron density between the two bonding atoms. Previously, what was there? Only one orbital was there. And that orbital could pay the attention, those electrons can pay the attention towards nucleus. But now what has happened? Because of overlap, now many electrons are there, those can pay attention towards this nucleus. Similarly, other atom nucleus, to him, many electrons are there, many electron cloud is there, large electron cloud is there. That's the importance of the overlap. And because of that many electrons and the multiple attractions, the bonding or the decrease in the energy or stability occurs. To that we say a covalent bond. So first postulate deals with the overlapping of the atomic orbitals. Because of overlap, stability increases. It is a first postulate. Is that first postulate clear?
Yes.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, if many unpaired electrons are present, if one unpaired electron is present, other atom also has one unpaired electron, then the overlap between the electron cloud is going to occur to establish or to form the covalent bond. When many unpaired electrons are there in the valence shell of an atom, which will make able to that atom that to form many bonds. Multiple bonds will be there if many unpaired electrons are available. For example, if I think about hydrogen, one S1, so one hydrogen has one unpaired electron, other hydrogen has other unpaired electron. So those electrons will overlap and can form only one bond. If I consider, say, oxygen, will anybody help me? What's the atomic number of oxygen?
8.
8.
Right, 8. So its electronic configuration is 1s2, 2s2 and 2p4. Let me show here. Okay, here I write that electronic configuration for the oxygen. Atomic number of oxygen is what? 8. Just wait. No, I could not able to understand the problem. No, actually I wanted to show you by that writing, but I think it is not working at this moment. Okay, it may be because of the image is there. Yes. If I consider oxygen, atomic number 8, what is its electronic configuration? 1s2, 2s2. Yes, help me. How many electrons will be in the p orbitals?
4.
4.
Yeah,
4.
4 electrons will be there. So that outermost suborbital and its electronic configuration only I represent. It is a p orbital, px, py and pz. So 4 electrons, how can I arrange? First electron, second electron, third electron, and it is a fourth electron. So similarly, if I consider the other oxygen atom, then that oxygen atom also will be with the same electronic configuration. That's a 1s2, 2s2, 2p4. So in one of the p orbital, 2 electrons will be there. Here only 1 electron and here 1 electron. So what may possible here? This one unpaired electron from one oxygen and unpaired electron from other oxygen, they will overlap to form one bond. Let me see who wanted to enter. Rina. Similarly, the unpaired electron from one oxygen and unpaired electron from other oxygen, they will overlap. So answer for my question here, in O2 molecule formation, how many bonds will be there? Yes, number of bonds will be total number of bonds. In O2 molecule, how many bonds are there? Just now I said how many bonds are there?
2.
Yes,
2.
2 bonds are there. So those 2 bonds are because of these 2 unpaired electrons. Here also 2 unpaired electrons are there because of that 2 bonds are established. Similarly, one more example that I give it to you. Just wait. Say nitrogen. This can be formed by 2 nitrogen atoms. Yes, what's the atomic number of nitrogen? 7. So what's the electronic configuration? 1s2, 2s2, 2p3. Let me represent that electronic configuration in terms of the block diagram. I am representing only the last subshell. That's a 2p. So 3 electrons are there. How can I represent those 3 electrons? That's a 1 electron, second electron, and third electron. Answer for my question. In case of nitrogen, how many unpaired electrons are there? Yes, unpaired electrons are 3. So because of that, what we expect? How many bonds should be there?
3.
Yes, number of bonds should be 3. How can we understand that those number of bonds? I have to consider the similar other nitrogen atom. Again, the 2px, 2py and 2pz orbital. Electrons are there. One unpaired electron is there in each orbital. And now what will happen? This one unpaired electron and other unpaired electron, they will overlap to form one sigma bond. Second unpaired electron and second unpaired electron of other nitrogen, they will overlap to form sigma bond. Similarly, a third unpaired electron and third unpaired electron will form sigma bond. So such 3 bonds are there, sigma or pi bond, that we have to discuss. But here one mistake I did during overlap. What exactly should be there? while overlapping, those electrons should be with same spin or opposite spin. Electron has a spin quantum number. So spin should be same or different during formation of bond. That's the question.
Different.
Yeah, spin should be what? The different. Then only the covalent bond formation takes place. Yes, that's the understanding of this second postulate. Presence of many unpaired electrons will result the multiple number of bonds. Example for that is O2 molecule, N2 molecule, and similarly from the organic chemistry also you can find the different multiple bonded compounds. But here what kinds of bonds are there? I'm discussing those bonds what later on. Is the second postulate clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now see the third postulate. Covalent chemical bonds are directional and are also parallel to the region of overlap. Means non-directional bonding, that's ionic bonding. That concept is clear to you now. Where particular way of approach is not there, particular direction for approach is not there, but here particular approach will be there because orbitals are aligned in one direction. So in the direction of orbitals only further orbital come, then only overlap is possible, and if overlap is possible, then covalent bond formation is possible. So what it indicates, that covalent bond is directional bond. If it is a directional bond, then it will give a particular structure for the molecule. Molecule I am saying. Crystal structure part is different. Now here molecular structure we are discussing. So if you consider the water molecule is angular, but geometry point of view you can say the tetrahedral. Methane molecule, the tetrahedral geometry you will say. It on what basis? On the basis of the covalent bonding. Various theories are there with which we can discuss the formation of those molecules. So third postulate is regarding the directional approach of covalent bonding. Is that third postulate clear?
Yes, sir.
Yeah. What was the first postulate? It was related to overlap. Unpaired electron from one, unpaired electron from other, orbitals of one, orbital of other, they will overlap and will result the covalent bonding. Is an interesting first postulate. Second postulate is there multiple unpaired electrons are there, multiple bondings will be there. Examples also I had given. Yes, which examples I had given for the multiple bonding?
Oxygen and nitrogen.
Exactly. Third postulate is about the directional approach of the covalent bond. Because of that particular geometry will be there for the molecule where covalent bonding is there. And the last postulate is about the sigma and pi bonding. When sigma bond forms, when pi bond forms, it is because of difference in interaction, difference in overlap. If there is an axial strong overlap, then sigma bond will form. If lateral overlap, then pi bond will form. So sigma and pi bond both are the covalent bonds only. Only extent of overlap, amount of overlap, amount of interaction differs. Therefore, these two different names are there. Let us understand this by means of few overlaps. I hope you could able to pay attention towards these diagrams. Pictorial presentations are there. Here see, it is a s orbital of one atom, s orbital of other atom. And these two are going to overlap to result these sigma bonded s orbitals. Our result is one sigma bond. Now question arises, why I am saying this bond as a sigma bond? Because there is a direct approach, head-on-head collision. One time I had given the proper explanation why sigma bond is stronger than the pi bond, accident, collision, with which I explained. Here there is no other option. Lateral overlap is not possible. If possible, then direct only. Lateral option is not there in SS combination. If I come to the second kind of the overlap, see here. Here is a one of the p orbital, here other p orbital, and those p orbitals are approaching laterally, means two vehicles are going parallelly, and among them how the collision takes place now. So that a lateral overlap, sideway overlap will be the result. But whatever this diagram is given, it should not be forward the pi bonding. This diagram is there for the sigma bonding. Means it is p orbital and p orbital. If I consider axially, then this diagram is possible. So this arrangement, whatever is shown, don't go on this arrangement if you have to understand sigma bond. But if you have to understand pi bond, then don't go on this final representation. How will be that representation? I'll explain to you later. Are you following, students, what I'm saying?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes. Thank you. Yes. See here the s orbital, spherically symmetric. The p orbital along axis. So those two can overlap, and that overlap is a direct overlap, head-on overlap. So what will be the result? whatever this result is there, that will be the which kind of bond? Sigma or pi? Yes, help me.
Sir,
So
repeat
I'm finding that you are
question.
not happy to answer. I want to had your answer also. See here, S orbital and P orbital, there is a direct overlap, head-on-head overlap, head-on-head collision. Then which bond will
Sigma
form?
bond.
That was my question.
Sigma.
Right, sigma bond, sigma bond. Yes. See
Sig-
here, one is other particular example. That's a hydrogen. That's a hydrogen electronic configuration 1s1. Other hydrogen electronic configuration 1s1. Electron from first hydrogen is shown by blue color. Electron from other hydrogen is shown by one of red color. And those s orbitals will overlap to produce here one bond. I want help from you. Which bond it is? Sigma or pi?
Sigma.
Right, sigma. And whichever these two
Sigma.
electrons are there, those are the common electrons. Yes. Energetics is explained. I'm coming to that toward the energetics. Now about the pi bonding, I like to give the explanation. Yes, just wait about the pi bonding. Let me see further. First, who wants is Gitanjali. Yeah, I represent it here later on. Yes, I hope you could able to understand this new diagram. Could you able to pay attention towards it? These two orbitals are shown here, which are overlapping. See here. Let you consider the pz orbital. This as what the z-axis. This also as what the z-axis. So this orbital is a pz orbital. This orbital also pz orbital. So pz orbital and pz orbital, they will overlap. And here, answer for my question. This overlap, which kind of overlap it is? It will result sigma bond or pi bond. Yes, which kind of bond it will give?
Sigma.
Right.
Sigma.
It will give the
Sigma.
right sigma bond. It will give because of direct overlap. Two electrons are there. To the two electrons are involved for the formation of one covalent bond. Now think about this blue colored, blue region orbitals. Say px orbital or py orbital. So this is the one upper lobe of the one orbital. Similarly, upper lobe for the other orbital. These two will overlap to result which kind of bond? Sigma or pi?
Pi bond.
I want.
Yes, with the pi bond. So pi bond because of the lateral interaction, sigma bond because of the head-on-head interaction. So examples if you want to give. So what oxygen molecule, there how many bonds are there in the oxygen molecule that we have concluded? In O2 molecule, two bonds are there. If two bonds are there, then it means what? One will be the sigma bond and one will be the pi bond. Are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Okay. If I consider the N2 molecule, how many bonds are there in N2 molecule? 3 bonds are there that we have discussed already. So it means whatever the 3 p orbitals are there, all are involved in the bonding. If I consider pz interaction as a sigma bond, then remaining 2 orbitals, say the py orbital and the px orbital, they will form the lateral interaction and will produce the pi bonds. So 3 bond means how many sigma bonds will be there? There will be the 1 sigma bond and number of pi bonds will be 2. Are you getting what I'm saying?
Yes, sir.
Yes. That's the
Yes,
understanding about the sigma and pi bonding. And this sigma and pi bonding approach applied to the hydrogen molecule by Hitler and London. These two scientists I am saying. And they have advanced this valence bond approach. Then what exactly this valence bond approach? Valence bond theory considers the quantum approach. Valence bond theory considers the quantum wave. One electron means in oneness orbital of hydrogen as a wave. So if I have to represent here, just wait. I am learning on this now, the style or tab or pad you can say. So bear with me. What valence bond theory considers? Valence bond theory considers one hydrogen where oneness orbital is there, that oneness orbital as a one wave. So we are considering that that's a oneness orbital as a psi function or psi as a wave function for this oneness orbital of the hydrogen. Similarly, other hydrogen also will be with the wave function psi 1s, or you can say psi 1 and other will be as a psi 2. That also will do. These two wave functions will interact to result a new wave function, say psi. This psi1 was representing the 1s orbital of one hydrogen, psi2 was representing the 1s orbital of other hydrogen. Now psi will represent the molecular orbital, that's a sigma 1s orbital, molecular orbital 3 you have studied, for that the hydrogen molecule. But here we are discussing the valence bond approach. So one wave function interacts with other wave function to give resultant wave function. This wave function itself has no physical significance, but it's used to find the probability of existence of the electron, probability of finding the electron cloud we can find, and energetics also we can find by means of the Schrodinger equation. When the wave function, which wave function? The psi wave function, resultant wave function, was solved mathematically using Schrodinger equation, it was found, just wait. It was found that energy at the beginning decreases up to particular limit, and then it what increases. So what I am bringing it to your notice, the energetics during the formation of the hydrogen molecule that I am discussing. Could you able to pay the attention towards that energy level diagram, or shall I magnify that?
Magnify.
Okay, I'll do that. Yes. Could you able to read now?
Yes,
sir.
Only the curve you should see. What are you finding? When these two hydrogens are away from each other, are far away from each other, potential energy means here if I consider the potential energy curve, here potential energy 0 means straight if I consider, straight line if I consider, that potential is nearly 0. Here if I consider potential energy is nearly 0. So as they approach closer, the potential energy decreases. See here, means they are approaching closer, and potential energy will decrease, but after some time you are finding sharp decrease in the potential energy, but up to particular limit. This position is a very important one. This position I am talking about, it is a equilibrium position, a standard position for the bond formation, because attraction was increasing as we bring closer, but there is a limitation for every aspect. So attraction has a limitation. Afterwards, what happens? Repulsion starts to develop. Attraction is there, but repulsion dominates. Then one may be the question, is there no repulsion here in this situation, in this part of the curve? Yes, of course there is a repulsion, but repulsion was less relative to the attraction. Attraction was dominating, and at this position, now what we are finding, equilibrium position, attractive force and repulsive force, attraction and repulsion, both are equal, equilibrium position. There is a bond formation. Which bond? Hydrogen bond, covalent bond, about which I am discussing. But if you further force to bring these two hydrogen closer, then because of repulsion, the energy will increase. It is because of what? The repulsion, because we are forcing them further to bring closer. So the idea what we were carrying, that if we bring the atoms closer, then the energy will decrease, that no longer is applicable. It is applicable up to this region. Here it is applicable. Yes, up to here it is what applicable. Here. After that, this idea is not applicable. Repulsive force dominates over there. So who dominates, that will decide the energetics of the formation of the molecule. So what valence bond theory says, the hydrogen, this hydrogen, that's the one hydrogen, which has wave function say psi1, other hydrogen, say the wave function psi2, they will combine to result a new wave function psi, which can be obtained by simple combination of psi1 and psi2. Students, whatever I am writing, could you able to read that?
Yes, sir.
Yes. So whatever this equation I represented, that equation is a valence bond theory equation, valence bond approach. Previously only in terms of the wording that I said. Now here particularly I had given the wave function. Wave functions do combine. They do overlap to result the new wave function. Energy will differ. So when we solve this equation, then we will get the energy, actual energy for the formation for the hydrogen molecule. But when people worked with the experimental determination, and the reality. It was found that the hydrogen molecule, when really forms, is considerably lower in energy. That which where this equilibrium constant is there, no equilibrium portion, this equilibrium portion is considerably lower in energy compared to this valence bond theory approach. Now question arises, how to explain those all? Then in order to explain the real formation of the hydrogen molecule, Hitler and London have given their approaches, have given their suggestions, have suggested few improvements. So total 4 improvements are there, those they have suggested. So I'll discuss those 4 improvements. Before that, let us know this valence bond theory approach in some more proper way. What exactly happens there? Why the energy decreases? Yes, here there is a one hydrogen atom, and if you consider any atom, then the 2 things will be there. One thing is a nucleus, that's the nucleus, and other thing is electron or electron cloud. Same thing is in case of other atom, nucleus and electron cloud. I want your help. What do you think? Nucleus, nucleus, there will be attraction or repulsion? Nucleus, nucleus, attraction or repulsion?
Repulsion.
Right,
Repulsion.
repulsion. Repulsion. Electron cloud, electron cloud, electron, electron, there will be repulsion. But if you consider nucleus and electron, nucleus of one atom, electron of other, you will find there is attraction. Electron of one and nucleus of other, you will find attraction. So there are the 2 causes of the repulsion, nucleus, nucleus, electron, electron, and 2 causes or 2 reasons for the attraction, nucleus and electron of other, and electron and nucleus of other. But where there is a more attraction and more repulsion, that will be decided by means of internuclear distance. So whatever these 2 atoms are there, between them how much distance is there, that affects. So when the 2 friends are there or 2 persons are there, the far away, one is India, other is in America, there may not be interaction. Now forget about the web applications or the internet applications. So there is no, but when the 2 friends somewhat come closer, means after a long break or long with, now what happens, you are at your residential place preferably, so your friend circle is limited regarding the classmates. Suppose if the college begins, then even if you see your friend, then some kind of the attraction will develop, and because of that the attraction energy decreases. It's a basic principle of the chemical bonding. Wherever there is attraction, more attraction, the energy level will decrease because there is stability. But up to particular limit, when the same friends come more closer, the chances are their repulsion will begin. So repulsive forces begins when attractive forces considerably dominates, and attractive forces becomes too much, then repulsive forces goes on dominating. Repulsive forces are short-term process. 2 friends also called brother and brother, many times the quarrel remain because they are too close, and because of the too closeness, repulsion may be what the more. It is not always, but here it doesn't mean there is a no attraction, but too much closeness can give here the repulsion, because the short duration or the short term repulsive forces, nucleus, nucleus, electron, electron, will dominate. I am not saying attraction is not there, attraction is there, but repulsion is what the more dominating. And because of that, after this equilibrium position, you were finding there is an increase in the energy. So students, is this potential energy curve for the formation of hydrogen molecule simple approach? Is it clear to you?
Yes, sir.
Yes, sir.
Where is repulsion, where is attraction? Okay, very good, very good. Now one may with the question, if we consider electrons with the same spin, is what I want to say. See here, this hydrogen has a spin of the electron, say positive spin. I am representing that, the positive spin. Other hydrogen also has the spin, say positive. Means it is like a north pole and north pole situation. If positive electron spins are coming together, then there will be repulsion rather than attraction due to the overlap. Here, the spin quantum number also played a very vital role. Overlapping is there, but electrons are with opposite spin, therefore north and south, how there is attraction, likewise attraction is formed there. But when both electrons are with the same spin, then there will be no attraction. Rather than that, there will be what? Repulsion. And energy for the formation for hydrogen molecule will increase. So potential energy curve will be this one. So that's the importance of the Pauli's exclusion principle. What Pauli said. So this curve, whatever you are finding now, so that is for what the when electron spins are parallel, then the same kind of the quantum numbers are avoided. But here, when the same spin comes over there, the repulsion will what form? Repulsion will be there. So molecule will not form. So this is the energetics for the formation for hydrogen molecule. Let us revise. The first point for the postulate was during the formation of covalent bond, what should be there?
Overlapping.
Yes, there should be the overlap. Second postulate, if many protons are there, then what will be there? If many protons are there, then what will be there?
Multiple bond with other atoms.
Multiple covalent bonds will be there. Yes, multiple covalent bond. And third postulate regarding the directional property of the covalent bonding, resulting the proper structure of the geometry for the molecule. And fourth postulate is regarding the sigma and pi bonding. Regarding for that, the different examples also were given to you. Afterwards, I came to explain the formation of the hydrogen molecule. And that hydrogen molecule energetics I went on what explaining. Then I considered the one hydrogen, other hydrogen, far away from each other, potential energy is 0. Then as they approach closer, as the internal distance decreases, energy will decrease up to particular limit, and afterwards it goes on increasing that the limiting position, equilibrium position is a bond formation position. Why the energy decreases? Why energy increases? Now answer for my question. Two ways for attraction, just suggest me, where are possible attractions when two atoms come closer? Yes, attraction is between whom?
Nucleus and electron.
Nucleus of one atom and electron of other. Yes. And second kind of attraction, electron of one and nucleus of other. Yes. Are you following what I'm saying?
Yes, sir.
And about repulsion, electron or nucleus, the repulsion will be there. So at the beginning, the attractive force remains dominating, and afterwards, means in short duration, short distances, repulsive force dominates. So these are the cases where the electrons are with opposite spins. But if electrons are with the same spin, then the energetics will be different. What will be there? Potential energy curve will increase. There will be no bond formation. So combining electrons should be with the opposite spin also is a concept of the valence bond theory. Mathematically, if we have to express, then how can we express? Psi1 is a wave function for the one atom. Psi2 is a wave function for the other atom or the electron cloud. That results psi as an electron wave function. Psi is equal to psi1 into psi2. That's a simple valence bond theory approach, but it is not perfect. It could not explain the real energetics of the formation of hydrogen molecule. This is what I am saying. Whatever this energy is there, it is 0. So it is a lower. It is 24. Minus 24 kilojoule per mole. That much stability is governed by the hydrogen molecule. Or during formation of hydrogen molecule, this 24 kilojoule per mole, that much amount of energy is evolved. That's the meaning of this diagram. That's the meaning of this equilibrium position. That's the importance of this valence bond theory approach. You will surprise if you know the in true sense. It will be time. Minimize this diagram so that it will be easy for me. Oh, this curse. So I can remove this curse. Rather than that, let me come here. Just could you able to see the screen now? Blank screen? Yes or no? Blank screen. Are you finding blank screen?
No, sir.
No.
Okay. Only that screen is where presentation is going on. So I have to come there only. Yes, in true sense, when hydrogen molecule formation occurs, then energy at the beginning slowly decreases. It is true. Then it suddenly decreases and considerable decreases there. And that decrease is up to this equilibrium position now I'm talking about. This equilibrium position is with the value 458 kilojoule per mole, this equilibrium position. And what was the situation for this equilibrium position? It was 24 kilojoule per mole. So where is 21, where is 458? What does it mean? We could not explain satisfactorily the formation of hydrogen molecule by simple approach of valence bond theory. And if you have to see about the internuclear distance, then internuclear distance also oh, there is a difference. What has happened here? This, if you see internuclear distance, if I talk about that, let me choose the other pen. So here at this position, internuclear distance, it was found that internuclear distance is 0.9. Okay, 0.9 angstrom. Means you can say actually it is what, the 9.1. Okay, I remove that now. 9.1 nanometer. 9 or 9.1 nanometer. But in true sense, means practically, this internuclear distance about which if I have to talk, this internuclear distance is 7.4 nanometer. So 9 nanometer is a wider, large distance, bond length is more. And when actual molecule forms, the bond length is less, means true. Practically, whatever the reality is there, the 7.4 nanometer of bond distance, that is not explained by the simple approach of the valence bond theory. Therefore, we need to study the improvements, and suggested improvements are 4. Who have suggested those improvements? Hitler and London. So what I feel, we'll discuss these improvements in the next lecture. But what exactly happened there in the valence bond approach? Just I informed to you. So it seems to be simple, but simple approach when we consider, reality is not explained. What is the purpose of theory? Theory should explain the practicality. Theory should explain the observed thing. Yes, students, are you following what I'm saying?
Yes, sir.
Yes, sir. Yes, sir.
Yes. Yes. So next lecture, I'll discuss the 4 improvements suggested by Hitler and London. And those improvements are applicable for our day-to-day activities also. I'll discuss that with example. We will understand that, and afterwards the various formations. So next week, the major portion of this second bit I am going to cover. Afterwards, further 2 lectures may be the sufficient. So by the end of this month, we will complete our syllabus. If anything is left, the first week of October will be needed. And in the month of October, I don't know the exact date, your examination will be there. The pattern of examination, about we also have no idea, but let it be any pattern, you should able to answer. So concept should be made clear. It is my responsibility that I did. About that, if any problems are there, then you can ask. Today is my first day to work with the pad. So if any flaws are there, forgive me. Improvement certainly will be there very soon. Yes. Any doubt or any question?
No, sir.
No, sir.
Yeah. Whether all are replying? Are you completing assignments? Any problem to complete assignments?
No, sir.
No, sir.
Okay. Yesterday, which lecture I had conducted, the last date given is 25th. Otherwise, many assignments are there. Up to 28th, you have to complete. You have given me the commitment, so you have to fulfill that. But even if problems are there, bring it to the notice in advance. I want assignment completion from everyone. So for today's lecture, the assignment is whatever I discussed, the postulates of valence bond theory, mathematical expression for the valence bond theory, energetics for the formation of hydrogen molecule, sigma bonding and pi bonding. The diagrams will come under the postulates only. So simple approach of valence bond theory, up to which you have to prepare the notes. I am not giving any study material. You can go to the video and you have to prepare the notes. Is it possible?
Yes, sir. Yes, sir.
Yes, sir.
Yes. If anybody has taken the snapshot during lecture only, then also will do. But you have to prepare the notes properly. Because during lecture also you can take a snapshot so that easily you can prepare the notes. Okay. Shall I stop now?
Yes, sir.
Yes.
Yes, I stopped the recording and